everything we've done so far, it all goes back to the first section that we started, which was just the simplifying stuff. And today what we're going to do is we're going to be writing from root form to exponential form, but guess what we're going to do after? We're going to simplify it. So I gave you this just so you can keep it going in your head. That's why I think this test is so much easier than the last test. The last test had a lot of different things on it. They all go together, but it was a lot of different things that you had to do. This one, basically, everything you do leads to the same place, and that's to simplify. So, you all know how to multiply, you know how to rationalize denominators, then you have to simplify. And then today we're going to rewrite them, and then you're going to simplify. So, I think this test is going to be a lot easier. And we'll talk about the date of when that is in just a minute, because I think I just scheduled it. So I need two numbers that multiply to be 32, where one is a perfect cube. 8 and 4. Okay? Now, which one's the perfect cube?
8.
Some people get confused when they see the 4 because we're so trained for square roots, but we're doing cube root. Cube root of 8 is what? 2. So that's what you should bring out of the house. And the 4 is going to stay in the house. Then we have x to the 4th, so we're going to break this up to be x cubed and x. One of these comes out. This guy stays in. And then y to the 7th, we get y cubed, and then y to the 1st. So 2 of these come out. And then one y stays inside. And we're done. Okay? So that's the simplifying part. Go ahead and grab notes real quick for 6.4, rational exponents. And I'm also going to tell you, this is a really important chapter that you're going to see again. Maybe not the simplifying, but the writing between roots and exponents is really important, especially if you are if you're on the track to make it to calculus. You'll use it all the time. Actually, you know what? We just used it in college algebra last week for Thursday. So there you go. You're going to see it again, is my point. This is not something that's going away. Okay. The word rational means ratio, like a fraction, a fractional exponent, or fractional with roots. So what we're going to do is we're going to go from radical form, which is like square root, cubed root, fourth root, to exponential form, which is something that has an exponent to it. So the first thing I'm going to show you is kind of mathy. I'll use their letters. If I have the nth root of x, okay, so the third root, the fourth root, the fifth root, any root is what n stands for. The nth root of x, that's equal to x to the 1 over n power. Okay, this is important, probably one of the two most important things that you need to know. So this is like saying if I have the third root of x, I can write this as an exponent as x to the 1/3 power. So the root is the bottom of your fraction. So if I have the fourth root of x, what is that written as? X to the 1/4 power. And here's how you can remember that. I'm going to draw my tree. I just thought of it. Forgot about this. Okay. What do we call this? The fourth what? Okay, now right in here, it's the root. What is this? The third root. Where is the root of a tree?
At the bottom.
Let me draw you a little picture.
Which we got it wrong then?
What's at the bottom of our fraction? The root. It's not an earthquake and it's not an atom bomb, it's a tree. I'm sure there's a Berenstain Bear living inside there. Okay? The root of the radical is the bottom of the fraction. Here's why you need to know that, because we're not done. Now I'm going to show you something else. Okay, but remember the root of the radical goes, Carson, turn around. I'm going to end up moving you. Every time I look up, you are turned around. Okay. Now let's say, what?
Olivia's still on the hole.
Oh my gosh. I always do that. Gosh, and she even. Okay, so start here. Start here, okay? I'll wait for you to get a pencil because I'm kind like that. Okay. All right. So now let's look at this for the first time ever. If I have the nth root of x raised to the, we'll use m because we always use m and n. I don't even know what they use. I should look. Oh, they use m. So if I have the nth root of x raised to the m power, and I'm going to write this as an exponent, what's going on the bottom of this exponent?
The end.
The n, because that's our root. So the only thing you missed, Olivia, is this root always goes on the bottom because roots are on the bottom of a tree. Does that make sense? Okay. What do you suppose is going to go on the top here? Our last ones, now that we have spilled the beans, I have already started. The last ones had a 1 on the top, which I'll let you go back and write this stuff down. The last ones had a 1 on the top because all of this was raised to the first power. We just don't write that when something's raised to the first power. So what do you suppose is going to go on the top of this one?
The M.
The m. Because the power is on the top, the root is on the bottom. So you're always going to write it with the root on the bottom, the power on the top.
Crazy.
It is crazy. So let's see what they have for examples. You guys try to write this one.
Is that simplifying technically?
No.
The root of the root? Oh, that's a 7. I was
Okay.
so confused.
Write this as an exponent.
Square root, square root.
Okay, what's going on top of our fraction?
3.
3, and so what goes on the bottom? 7, the root. Okay, now let's go the other direction. Now I'm going to give it to you written like this, and I want you to write it as a radical. So let's say x to the 2/5 power. Let's write that as a radical.
So
Are
then
we going backwards?
Yeah.
that'd be the radical, yeah. So then are we eventually gonna have to like say it'd be like 3 to the 2/5 power?
Yep.
Solve that.
So we're going to take, this is going to become a number. We're going to write it like this, and then we're going to simplify. So, okay. What goes in the house here? X. What's the root of this radical?
5.
5. And what is it raised to? 2. Okay, I got to show you one other thing, because sometimes I always write it like this, but this means exactly the same thing. That power can either be on the outside of the whole thing, or it can just be on the inside. They mean exactly the same thing. Because sometimes you see them written like this. I always tend to write them like this and then work from there.
If you had multiple variables, would you have to distribute it to every variable?
Yep. Yep. That's why I usually write it out on the outside. Okay, let's say we have this. I'm going to math it up just a little bit. 7 to the 1/2 times 7 to the 1/2. Our goal for this one is to write it in radical form. So that's the roots, the radical. First thing we have to do is remember what we do with our exponent when we're multiplying the same base. Does anybody remember?
Keep it.
No. Keep the base. That part's right. You add them. I heard somebody say it. So what's 1/2 plus 1/2?
1.
1. Oh, that one's not fun. Because then there's no radical.
Yeah, that wasn't even math.
Sorry. No math.
Let
Here's what I bet I have written down. Oh, no, that's what they have. Where did I see it? Oh, I hand wrote it in up here. Here's what about this one? Let's do this one. This is much more fun. 7 to the 1/4 plus, or times 7 to the 1/4 is going to be 7 to the 1/2, because you have 7 to the 2/4, which is 7 to the 1/2. And what is that written as a radical?
2.
7 on the inside.
2 in the.
Okay, do we usually write that when it's square root? No, so this is just your answer.
That's not bad.
Yeah, and then she can like add something.
Okay, well now let's do some real ones.
Oh, I thought that was math.
No, right now, the first part of our thing is to go from root form to exponential form and back. Okay, so you understand where the top and the bottom number come from. Now let's apply it to a number. I'll start off easy. 16 to the 3/2 power. Okay, I want to write this in radical form. So what is my root here?
16.
No, 16
2.
something. 2 is the root, which we don't write, and it's raised to what power? 3. Now, as you guys are working, I'm not going to count you wrong if you write a 2 in for that, just to be, so do whatever you need to do. What's the square root of 16? 4. Then I'm going to do 4 to the 3rd power is 64. So 16 to the 3/2 power is equal to 64. I did my root first. Everybody knows the square root of 16 is 4. And then I had to raise that to the 3rd power.
It's 16
Are they all gonna be added?
16 times 4.
Yeah, they're not bad. These are not bad. Okay, let's try another one. Let's try 32 raised to the 2/5 power. 32 raised to the 2/5 power, and then I'm going to let you guys work so you have the rest of the time to work. You guys try this all on your own.
5 times 5.
Okay. Okay, what is the root? What root are we using? 5th root of what? 32 raised to the 2nd power. What's the 5th root of 32? 2. 2 times 2 times 2 times 2 is 32. So now I have 2 squared, and that answer is 4. Pretty easy? Okay, your homework today is actually pretty easy also. And there's not that much of it, so we might go over this in class. We might save it for tomorrow.
When I was gone.
Okay, just set it on my.
Okay.